Hi, my name's Kurt Seifried, and today I'll be talking about speedrunning AI security, basically using the last 14 years of cloud security knowledge and guidance to get us closer to AI security faster. So first, a quick disclaimer. I'm not endorsing any of the companies and the services I'm talking about here, but the reality is we can't talk about cloud without talking about Amazon, Azure, and Google. And we can't talk about, cloud services like remote file storage without, of course, talking about things like AWS S3, for example. And I'll only be referring to publicly known information. And then a quick disclaimer about the speedrun metaphor. Uh, in a speedrun, you typically get to the end of the game and complete it. As we know in security, there is no finish line in security. It's an ongoing struggle. Attackers keep coming up with new things, defenders keep coming up with new ways to deal with them. But we can get 80 to 90% of the way there quickly using the existing AI or the existing cloud tools, techniques, and standards applied to AI. Because the simple truth is we don't have 5 to 10 years to make AI really secure like we did for cloud. So this is the agenda slide. Basically, I'm going to talk about a quick bit of history, then the parallels, the fact that a lot of people think they're not using AI yet, some of the economics around cloud and AI security, and then on to the CCM Cake and Star, which, as you know, are some of the foundational cloud security frameworks and guidance. And then I'll talk about some AI-specific problems, the regulation and law that's coming, and then a quick summary and also the future of AI security. So history never repeats itself, but it does often rhyme, to quote Mark Twain. So a quick history of how the cloud and AI came to be. So with cloud, it actually started out with Sun, the network is the computer, but they were way early. Nobody had reliable enough bandwidth. There was no cloud management software. Computers were very slow. It's not like you could get 500 users on a single server without it dying. So that did not work out. But 2 decades later, it did. Amazon Web Services released in 2006, Google Cloud in 2008, and Microsoft in 2008. Those three ultimately became the hyperscaler cloud providers, and by which I mean they spend more than $10 billion a year in capital expenditures. I remember on a Microsoft earnings call, they were referring to their capacity in data center miles. And the cloud was doing well. Then COVID happened and it really took off, between work from home and supply chain disruptions, which we're still dealing with to some degree. I know sourcing servers can still be a lot harder than it used to be in the past. And cloud is now the default for many organizations. It's the new normal. And to say that in 2015 or back in 2010 was wildly optimistic. So AI, sort of the same thing. With AI, I would say one of probably the pivotal moments was the Turing test back in the 50s, which got the idea of artificial general intelligence into the public mind. But as we all learned over the last 70 years, artificial intelligence, especially AGI, is really hard. And we've had decades of research, tens and hundreds of billions of dollars spent. And I mean, the biggest success story for a long time was IBM Watson, which could win at Jeopardy. But it's not like you or I could actually buy access to Watson and get it to answer useful questions or generate useful content. Like it wasn't available as a service. OpenAI first released their ChatGPT 3 in 2020, and it was okay. It wasn't wildly successful. Some people kicked the tires. I remember looking at it and thinking, okay, this is neat, but it doesn't do anything useful yet. And then ChatGPT 3.5 came out in November of 2022, and it blew the doors off. It was wildly useful, and it reached 100 million users in about 2 months. And while that number is now dropping because the novelty's worn off, still 100 million people is a lot of people. So there's a lot of parallels in the history of how cloud and AI have come to be. So the parallels of cloud and AI, comparison is the thief of joy, to quote Theodore Roosevelt. So with cloud, you can build your own cloud. I mean, I used to work at Red Hat. I was on the product security team. I was actually their first cloud security hire. I was responsible for their cloud products like OpenStack and OpenShift. And you can buy basically cloud in a box between Dell and Red Hat or other server vendors. But the reality is you should probably just use somebody else's cloud, unless you have some really specific use case, like you're on an offshore oil rig or, you have privacy or regulatory requirements that preclude you from using a public cloud. As we've seen with the cloud, the general structure is you have infrastructure as a service providers, providing bare metal or VMs. You have platform as a service, so providing an abstracted access, and you can basically just give them a, a program and they'll run it for you, on top of something like Heroku. And then we finally have the software as a service providers, which is, everything from lower level infrastructure type things like email as a service, all the way up to high level things like, Salesforce or um, billing, credit card processing, your HR functions, all of that. And the success in cloud really is driven by this building services on top of other services. So infrastructure provides the necessary capabilities for someone to build a platform as a service, and the platform as a service provides the necessary capabilities for somebody to build the software as a service. And this, of course, has led to DevSecOps. So at the Cloud Security Alliance, the perfect example, we have a dev team, just under half a dozen people, and they are mostly a Ruby on Rails shop. And they basically just throw the code into Heroku, and presto, our website works. It's magic. I love it because as the IT administrator, literally the only thing I have to do is pay the Heroku bill once a month and point one DNS record at Heroku. And that's it. The rest of it is done by the dev team. And they do a pretty good job. We also have a shared responsibility model. So for example, in infrastructure as a service, for example, you can upload all your operating system, your data and everything, and you can also back it up as much as you want. And with at the other extreme, software as a service, for example, you can usually kind of politely ask for your data, but the underlying software and systems that run it are off limits. I don't think Salesforce is going to provide a copy of Salesforce with your data backup anytime soon. And well, with AI, it's quite similar. You can build and train and run your own AI. There's Hugging Face, and you can go down there and download your own AI models or download the trainable models. They even have data sets. But again, much like cloud, you probably should just use somebody else's unless you have some specific privacy or regulatory requirement. The care and feeding of an AI is very difficult and requires a level of expertise a lot of people don't have yet. And we're seeing the AI market develop much like the cloud market in that we have hardware providers. You can go rent time on A100 and H100 processors, provided by Amazon or Google or other providers. Then we've got the model providers like OpenAI's ChatGPT. They have an API. You can send it queries. You can modify the model training. You can provide it examples of what you want to happen. And then again, we have the software as a service, or I guess AI as a service, where literally they will, you point them at your website, they'll crawl your website and build a chatbot that can answer questions about your website content. So again, we're seeing the cloud paradigm of building services on top of other services. And we've even seen now, I don't know which of these two terms will win, but we've seen ML ops, machine learning ops, and AI ops. They both have about the same number of Google hits. So it remains to be seen which of those two terms becomes the more popular one. But to put it bluntly, the AI devs or ML devs are going to largely be responsible for running and servicing all their needs. They're not going to be sending tickets into an ops team asking them to please, retrain the AI model with the new set of data. That's not going to work. We're going to have this more modern DevSecOps style of operation. And again, with AI, we're seeing a shared responsibility model. So again, with the hardware provider, you would upload your AI model, you would train it, you would hopefully back it up and use it as you wish. And then all the way again to the software as a service, where they crawl your website. Well, they'll give you sort of the data that you uploaded maybe, but, they're not going to give you a copy of the trained model. Like for one thing, they're huge. And, things like the underlying software and the AI models are probably going to be off limits with most of these providers, just like they are with cloud. So the economics of cloud and AI security, and I apologize for using a military sort of metaphor here, but it suits. So the U.S. military operates 650 aerial fuel tankers. So basically, if they got rid of every single other plane they have, they would still be number 10 globally for Air Force by size. Combined, the U.S. military operates about 13,000 aircraft, which means if you glue the next six air forces together by size, so China, Russia, India, I forget the rest, you basically have as many planes, but you'd still be lacking quality and capabilities like the F-22 or the new B-21 bomber. Um, and so part of the problem here is with security at scale, there are just certain economic and scale realities um, that have, well, I'll go into this. So with cloud, the providers obviously have dedicated security teams. And the thing is, the hyperscaler players also have things like security coprocessors, right? They have designed, built, and deployed custom silicon security coprocessors. So that means they have custom motherboards, they have the software that manages it. You know, this is not something you can do for less than several tens of millions of dollars and a high degree of expertise. Cloud requires a lot of security spending, but it also requires a large fleet. So um, you can't build a statistical model of abuse without a lot of data. And you can't apply that statistical model of abuse to 10 machines. You need to apply it to 1 million machines. And that is what allows things like cloud providers to look at, for example, memory usage and CPU usage profiles. So not what it's actually doing, but just like how heavily used it's being, and to actually, with a reasonable degree of accuracy, determine if it's, abusive or um, like spam behavior or not, or if it's a real workload. And fundamentally, the cloud is always about building on top of other services that are secure. So, we pick an infrastructure as a service provider that is secure to run on top of for a platform as a service provider. And in turn, the software as a service providers, run on top of secure platform as a service providers. So a great example of this is, every time Amazon S3 has a blip, we get to learn which software and file sharing sites are running on top of S3 because they all go down. And so the idea is, I don't want to have to worry about, are the hard drives in the data center properly disposed of when they die, right? I want that to be somebody else's problem. And, Google and Amazon and Microsoft do a good job of that. And with AI, we're seeing largely the same thing, right? The AI providers have dedicated security teams, but the really big ones have dedicated alignment teams. So the AI alignment problem is essentially, how do we build a super smart AI that essentially doesn't, have a Matrix movie style outcome where it, kills all the humans so that it can optimize its environment for itself. And while we don't have general artificial intelligence yet, it's beginning to look a lot more possible. We've been promised it for 70 years, but it actually might be coming in the next 50. I don't know actually how much AI security costs currently, but I imagine AI security experts are not cheap, right? Running experimental AI models means training experimental AI models. And that means spending, tens, hundreds of thousands of dollars, maybe even millions of dollars on compute time and hardware to build essentially throwaway AI models to test things out. What happens when we add this data set to the model? What happens when we remove this data set from the model? What happens if we modify this data set to, to try and sanitize it and remove all the naughty words? You can't do that without spending a lot of money and time testing things out. Just like in cloud, you don't learn how to manage 10,000 machines without having 10,000 machines to manage. And again, with AI, we're seeing this. It's all about building higher level services on top of the lower level services. So, for example, I'm looking at one software as a service provider that you literally create an account, you give them your website URL, they basically crawl your website and spit out a trained chatbot. And as far as I can tell, under the hood, it's quote unquote just a customized OpenAI ChatGPT model, with API calls to it, which you could do yourself with some Python scripting. It's actually shockingly not that hard, but this SaaS provider is doing it at a price point where it's actually cheaper for me to pay them than to build it in-house, even if it is easy. Plus, then I don't have to maintain all the software. So that's, the exact same arguments around using a lot of cloud services. So a lot of people are not using AI yet, but your cloud providers are. So this week, of the 100 cloud providers that the Cloud Security Alliance uses, I did a quick spot check, and our core ones like Microsoft, Amazon, Google, Zapier, Miro, Ramp, Salesforce, Pardot, Grammarly, and so on, every single one of them now has an AI offering. Right. Uh, Currently, most of them are opt-in, simply because running AI and the queries, the API calls are still quite expensive. But given time, API availability and cost is going to come down, and thus AI features are going to come into your services as a default thing. Zapier is a great example. Instead of building a Zap by actually like choosing Google Sheets and telling it what to do, you can now describe something like, I want to process incoming email and extract the sender email address and the content of the email and put it in a spreadsheet and then feed that into another system. And it'll essentially build it for you. It's quite amazing. As I said, the AI usage is going to get cheaper. So either you build these features in or offer them at a very good price, or your competitors will. And the thing I think that's really compelling about AI is it's helping bridge the gap that programmers traditionally bridge, in that I'm trying to understand your system requirements and build you a solution or something that, solves your problem. And AI won't be perfect, but, if it gets us 80% of the way there with 10 cents worth of API calls, that's pretty good. But what this means is every cloud provider is fundamentally becoming a producer and consumer of AI services. And of course, there's also new AI-centric services like meeting transcription, summarization, and translation that I have now been using for 2 weeks, and I will never go back to not using. I've also noticed most meetings now seem to have, at least one or two free Otter AI accounts recording it. And so it turns out basically it's your cloud providers using and providing AI, and using existing cloud security techniques and controls will get us about 80, probably 90% of the way there. So the good news is there's a lot of AI in the cloud vendors, most of which have a public stars entry. And even more good news, there's some of the new AI firms already have embraced CCM cake and stars. So for example, this is a screenshot from the OpenAI website, and you'll notice they have a cake-like document. This is wonderful. Now, we are obviously going to need to tweak and add some things to the CCM cake and stars to properly support AI, especially as it gets baked into more cloud services and providers, right? Like CCM cake and star have a cloud-centric view of the world, not very surprising. And while AI typically runs in and on the cloud, it does have some unique properties. So let's talk about some AI-specific problems for a moment. Like I said, in general, AI security problems, you can apply, well-known security controls, like things like least privilege, having multi-factor authentication to your AI accounts. Obviously, all that's going to help. Sanitizing your inputs, right? Don't feed your AI bad things in the training model. We all remember when Microsoft put a chatbot on Twitter and let Twitter users interact and train it, and it went fully racist within the day. Same thing with sending requests into your AI. You're probably going to want to, make sure they're not too long or complicated or abusive. But obviously, this isn't going to solve every problem. So the dirty secret is we don't know what the major AI problems are going to be. We're about 7 months into AI, and we've honestly barely started using and integrating it with all of our other systems. And so right now, two problems I've seen come up in conversation a lot are the concerns around your internal data ending up in a training data set. And this can be partially addressed by, supply chain management, transparency, and accountability, which is already in the CCM cake and stars. And so by that, I mean, if you send data to an AI for processing or specifically to train your model, will it be used in other people's models? And can then your data potentially leak out or, be used by other people? And there are some legitimate concerns there, for example, if you have trade secrets. And then the other big topic that keeps coming up is the abuse management of ensuring that the AI doesn't create defamatory content or hallucinated content or just plain wrong answers. I was asking OpenAI about a piece of documentation that I wrote, the Linux Administrator Security Guide, and I asked it who wrote it, and it said a group of people wrote it, and I'm like, well, no, that was me. But I realized, for example, other people have taken the Linux Administrator Security Guide, copied it to their websites over the years, to get the search engine traffic. And so if you kind of crawl the web and look at it, well, I mean, it's scattered all over the web. It looks kind of like it's, written by a group of people because they've also stripped my name off of it. So, okay. Um, these training models are including public data for which, in some cases the copyright has been stripped off or the data has been modified. And so these training sets are not perfect. You by definition cannot review the training set and ensure that it is all correct, because even if you had enough people and time to do it, the effort would just be wildly impossible. So also I wanted to do a quick note on AI explainability and transparency. So in theory, I love the idea. Knowing how your AI works, why it works, why did it make that decision? What data was it trained on? What biases might it exhibit? Let's ensure it's not discriminatory. Would definitely potentially help me make better security decisions. But the harsh reality is 100 million people like myself decided OpenAI was worth using without knowing how it works. And I don't think that's going to change. So, on a related note, right? How many of you have ever declined to buy a cloud service because they did not provide an up-to-date, software bill of materials listing all the software and services that their cloud services relies and is built upon, right? That's never happened. So while I think AI explainability and transparency are nice ideas, they were first put forth sort of publicly by NIST. I don't think AI companies are going to want to give away the special sauce, the hints as to what's even in there. Even saying what's in your training data is a very sensitive topic now because a lot of that training data has been scraped from the public web. And well, as we're seeing with several lawsuits now, these people and companies seem to think they're entitled to some of the money. And obviously it's going to be a lot easier to avoid that if you don't give people a list of everything your AI was trained upon. So, like I said, I think it's a nice idea. I don't think it's going to be as important as people say it is. So, regulation and law, and this is a direct quote, the rules aim to promote the uptake of human-centric and trustworthy AI and protect the health, safety, fundamental rights, and democracy from its harmful effects. To put this in context, it's from the European Parliament. They essentially were also on camera as saying, look, we did not regulate social media, and look how that turned out. Oops. In the cloud, we have not really a lot of cloud-specific law, right? I mean, there aren't very many cloud-specific laws or regulations, other than, of course, GDPR and CCPA, right? That one has really ended up affecting cloud providers and the users. The CSA even, we do a lot of GDPR compliance work because even just simple things like we have the PII of the billing contacts of members for companies that, and organizations that join the CSA. And not surprisingly, a lot of these companies and organizations really care about compliance and ensuring that, all their data suppliers and sub-processors and partners and contractors and so on are handling PII correctly, even if it is literally a single record of one person. And so, as we all know, for larger companies, this is GDPR compliance is a massive effort. The good news is pretty much everybody ends up processing their data in California at some point. And, we just, It's an easy answer. Um, and with AI, well, we already saw OpenAI ChatGPT. It got shut down in Italy for a little while due to GDPR compliance and complaints. And then they changed it so that the chat history and your data being sent into their training models is now optional, right? You can essentially, if you have chat history turned on, your data is recorded and potentially fed into future training models. And if you turn your chat history off, the data is not fed into future training models. So you can opt out of the data collection. And it looks like a lot of governments really do understand that, like social media or other, groundbreaking technologies, AI has some risks that need to be managed, and they're not going to let this one slip. I personally really like the EU AI Act. It specifically splits AI usage into four basic categories: minimal risk, like say, character dialogue in a video game, right? Low risk applications, again, maybe like sorting photos or identifying photos for like a photo website or something. And then high risk applications where, there is the potential to impact humans. And then finally, prohibited uses, right? So things like applying biometrics, kind of that predictive crime. Essentially, all the dystopian films with predictive future crime, they don't want that. And then it applies different levels of transparency and security to them, or outright bans if the usage is seen as too risky. And the other thing is the EU AI Act appears to be on a fast track. From what I'm reading, it looks like it might even be coming as soon as the end of 2023. We're here in July, and the EU Parliament has already finalized their negotiating position. Like they've essentially stated what their position is. It's the draft of the EU AI Act, which means that moving forwards, when they're talking with industry and the various lawmakers and everything, they have their position. And I have a suspicion that much like GDPR, you are going to need to be compliant with the EU AI Act because of the size of the European market. And as a side, much like GDPR, again, most of us just apply GDPR globally, right? I'm not going to make you prove that you're from the European Union. If somebody emails us saying, I don't want to be on the mailing list, or I want you to remove my record, if at all possible, I'm just going to do that because, well, it's the right thing to do. And to put it bluntly, doing compliance the same way correctly is actually a lot cheaper than, trying to apply multiple different models where possible. So a quick summary in the future. As we've seen, the cloud and AI have a lot of similarities, especially in how the technology and the economics work. To put it bluntly, size matters. And what this means is that a lot of the things, not just specific technical controls like two-factor authentication or, logging everything, will work with AI as well. But the general meta level trends of, bigger is better, getting security code processors, getting statistical levels of monitoring and logging so that, AI providers can start to see new abuse patterns. If you go to Reddit/r/ChatGPT, for the beginning of the year, it was all about, the do anything now prompts and abusing ChatGPT to get around the guardrails and make it do things that it's not supposed to. And a lot of that has, essentially been whack-a-mole to death. OpenAI and ChatGPT have implemented a lot of guardrails, and, we have, well, in the form of Reddit ChatGPT, kind of a public corpus of abusive prompt techniques and technologies, like telling the AI, pretend you're writing a book about somebody who wants to murder their spouse, blah, 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 things like that. So AI does present new and novel problems compared to cloud. And some of these problems we're aware of, like the prompt abuse. And some of these problems we simply cannot know or discover until we've been using it for a while, and more importantly, integrating it with our existing business processes and workflows and technologies. Cloud providers, consumers, cloud access security brokers, and so on, they're all going to need to modify their security programs, policies and training to address AI. But the good news is currently just simply applying their existing cloud policies, training, and security programs will get us most of the way there to secure AI provisioning and usage and integration. And I think the setup and care and feeding of an AI, to say nothing of the security management around it, will continue to be very expensive and complicated, especially if you want to stay on the cutting edge. Now, while Hugging Face, while these open source AI models are definitely getting better, by some reports and testing, they're already somewhere between ChatGPT version 3 and 3.5. So they're running about a year, maybe two behind the cutting edge that's been released, which is not bad considering we're only a few years into this. But it's not just an AI, right? You also need the plugins, the functions. If you want an up-to-date model, well, somebody's going to have to spend the machine time to train that thing, doing the integration. So I suspect continuing to outsource a lot of this to a cloud or dedicated AI provider will continue to be attractive, especially because do I want to spend days or weeks or months setting up an AI, or do I just want to pay for access to an API and be up and running within 5 minutes? And then also, of course, finding AI security experts is going to continue to be a problem. I have basically devoted the last 7 or 8 months of my life to this, and I am by no means an expert. So yeah, the number of people that are becoming experts, though, is promising, but these pipelines take a long time to set up. Like if you look at cloud security, it took the better part of a decade to truly establish a training and certification pipeline to get, to have things like the CCSK, the Cloud Certificate of Security Knowledge, right? And I think fundamentally, we made the cloud secure and safe to use, right? There was a lot of naysayers at the beginning, that this could not be secure, that this was just somebody else's computer, that this would never be safe. You couldn't rely on it. It wouldn't be safe or reliable enough or secure enough. And clearly we got there, right? It's the new normal. It works. And we can do this for AI. But like I said at the beginning, we don't have 5 or 10 years to do this for AI. So finally, there's 2 big projects at the CSA with respect to AI that I'm involved in. The first one is the CSA has an AI usage policy working group. You can sign up there, our URL shortener. Basically, the idea there is we've identified a lot of the concerns that exist with AI usage, and we're trying to generate a policy framework and guidance. And we don't have guidance for everything necessarily. We do know, some knobs you can dial up and down with respect to what you can do with AI or allow and what the impacts will be, and some we just don't know. So it's partly an exploration of the problem and also an iterative feedback process where, we're going to release this hopefully by the end of summer, get people using it, and then, hopefully they'll come back to us and say, look, we implemented this policy and it had this problem or it had this benefit or, all of the above. And then the second thing that should hopefully be done not too long from now is I'm working on an AI copyright video that focuses not just on the AI output issue. As we all know in America, generative AI output cannot be copyrighted, right? And that seems to be a global trend, although that's not necessarily going to be the case. There are some jurisdictions that might decide that it can be copyrighted. But more importantly, I'm looking at the issues around internal material being used for training AI models, which seems to be an issue that's holding a lot of people back from using AI effectively. And of course, the problem is that AI works much better with more context and information. It's if you can provide it with the data, you can do what's called grounding, and you can literally ground the AI to, kind of keep it sane and prevent it from hallucinating or making something up. And this video and these materials will be announced through the usual CSA channels. So with that, I'd like to thank everybody for taking the time to listen to this. Yeah, have a great day. Bye.